Module 4, we're talking about two interrelated topics. One is the string, which is technically words or variables that are delimited by quotes, single or double. And then we're talking about lists, which are collections of data, be they strings such as this, or booleans, or number types. I wanted to put them together because whenever you have, and you'll kind of see why, but to give you the cliff notes, I like to put lists and strings together because strings are fundamentally arrays of characters, and they're a list of characters, if you will. Python really prefers to think of collections of data as lists rather than arrays. And when we think of characters in this way, you're kind of constantly sending these arrays or these lists of characters around the internet. And I think in average everyday programming, this is a fun exercise to kind of take apart strings and to take apart lists. But when you think about the larger story of the internet and how Python fits into that, be it as a data scraping mechanism or as a big data mechanism or as a data science mechanism, Python is constantly ingesting characters. They're constantly ingesting lists of characters. And so I think this week, this module, we're looking at strings, but I think in the larger application, you're really thinking about the internet, and you're thinking about the internet as an internet of lists. And a message is really a list of lists, or a list or a collection of lists of characters. A message is a series of words. A word is a list of characters. And so we'll talk about how to handle and decompile, if you will, those lists of characters. Day to day in the intensive work of programming, be it Python and data science, or in machine learning, or in whatever application, whatever software engineering application, you really have the need to handle words. And it strikes me as kind of an important reason why we teach this lesson is the fact that data science is really, the data scientists and the machine learning people are challenged very much by what you're doing this week, which is the ingest of characters and the processing. For example, we're inserting elements to a list, and you can see here we're creating these lists, and applications and other pieces of technology are constantly creating lists. It could be a sensor, it could be a questionnaire online, it could be a program like this, which is collecting characters that are coming in from my microphone or my camera. So lists are constantly being created, and a lot of those lists are eventually becoming strings or collections of strings. They're being sent around the internet. But what challenges data scientists, machine learning people, is not the finished string. Usually that's a nice thing to have, but it's being able to manage those strings and work with them. That really separates really professional programmers from non-programmers. In the future, everybody's going to be working with data. I can see it already from other business students. They're all really preparing to be data intensive workers. People are, preparing to work from home. The level of technical skill is being elevated on a per person basis. You can expect the average professional in the future to have a lot of data capability, and that's good. It just means that the future is more data driven. So I think, and I'm just giving you a little preamble before we jump in, in the future, we're going to have programmers who work very closely with strings, and we have people who work with the end product. We have people who work with CSV and other files that are composed of data. And, so I think we do classes like this because we want you to be in that upper tier of people who can help to, quote unquote, wrangle data and help to take in data and then transform it in a way so that when it comes time for people to analyze that data, it becomes very easy to do. We find that many data analysts really need data to be in a nice finished product. It needs to be in a nice looking list. It needs to be made into a JSON or a CSV. It needs to look like this at the end. But there has to be people who really know how to make the machines that collect the data, and those are the software engineers. So that is where a class like this is pointing you. So let's go through some of the fun parts. That's the big picture. You guys are adults. You like to know how this fits in with things. Here's a great example of a string. Now I can name this whatever I want. Prefixes, that's something I've made. Suffix, that's something I've made. Then this is the content of that variable. So the machine, it creates a space that's labeled prefixes that contains this content. And this is, of course, a string. And a string is a list or an array of content. An array, by definition, is just a series of characters or number types that are stored right next to each other. And so be it a list or an array in other languages, it's defined by storage that is happening right next door to each other. So if we were to create a list, we would have one piece of data that lives exactly next to each other. And so when we undergo a for loop and we iterate the contents of that list, and list here is empty, and then we populate it. If we iterate that list, it happens very quickly because the members of that list live in the operating system right next to each other. And so strings are lists, but they're lists of characters. And then we can utilize the list type to store data. So in this case, we're storing a random integer between 0 and 1,000. And we utilize that range. We create something, and then we are summarizing it here. So when we go back and we look at strings, we know that we could create we could create a numeric type by going like this and adding decimal points or not adding decimal points. That's an integer. That is a float type. But if we were, and so that operates numerically. So, if we were to say this, and then we were to say, something along these lines, we are doing a bit of arithmetic with these numbers. But if we were to put quotes around them, they no longer process numerically. They are handled as characters. And so this will show up as a non-number. It shows up as a string. And a string, we should stop calling them strings, but it's just the history of computing, the history of compilers. People call them strings. They are strings of characters. That's fine. But you can see how it's being treated differently because we have arithmetic flying around. So these are going to be evaluated as words, and words, they will have a particular length or a total number of characters. And I'll let you go through this. Now, the same thing happens with lists, where let's say we have a list, and let me give you the primitive. We begin with a list right here, and we can add things to them. And we'll never add things by hand. It's so rare that we add things by hand. We can create somewhat of a constant where we specify a set of categories or a set of words, and maybe we make a menu from this. That's fine. But it would be extremely rare, maybe once every couple of years, where you hand code a list. Most lists get added dynamically. So you have an application or a sensor or a data mining app where you're kind of sucking down numbers or data from the internet, but rarely are we going to hand code this. But so when we do this as an instruction, we're hand coding something. And then we can add things to this list, and it gets added to the back end of the list. And so we can add here, let's add things to it. And you can see that it gets added to the rear of the list. And this 76, let's call it 44. That should be added at the top end of the list. So the reason why we can upend this is, and you notice right here that 99, you're saying, well, 44 should be at the front because it begins at the front. And I'll sort of read it. Let's say 33, this big number is at the front. And you're saying, well, wait a second. 99 is at the front. Why is that? And it's because I inserted 99. And let's put a big number right here just so it sticks out. I inserted this at position 0. And I did that to prove that there's position 0, 1, 2, 3, 4, 5. And so if I were to say, well, put that at position 4, that's going to move it back, and it will respect that position of 0. Now, if I wanted to mess around with the order here, that puts cat at the very start. Now, lists do not care so much about the type of data that is sitting at each stage. I'm sure if we were to iterate this with a for loop and then talk about the type of each of these variables, each of these are different types. So that's a string, that's a Boolean, that's an integer, that's a number type, a float. So we can append at different locations. Now we also want to say, well, what is where inside of the index is hello? And hello, I believe, is 0, 1, 2, 3. So that's position 3. And then what is the count of 76? How many times does 76 occur within this list? And so maybe we'll put a few more in there just for fun and challenge it a little bit. And so we have a bit more. And then, if we put just to fool around with that. And it's good to know that that is the character of things, and of course, my list has these right here before we're going to add Apple and 76 later. Now we can remove one of the 76s, and then we're going to go ahead and pop the index of true, or the location of true. And you'll realize that if I should have true inside of that, and I want to illustrate this. I normally have true inside of this list, but if I'm going to go ahead and pop it, then that will remove that item. So true is a part of that array, and now if I'm going to pop it, the true disappears. And if I don't pop it, then it will remain there. So pushing and popping are a big part of lists. Pushing or appending is when we're adding something to that list. Then we can insert is like adding, but we can specify a place. So we can insert it tactically. And then if we want to remove something, we go pop. Now, I think true is there quite a bit. What if we were to pop the value of 76? The index of 76, remove 76. And so that operates on the first 76 right there. The other 76 remain, but the first 76 is removed. So it does it once. Typically that 76 will be there. So let's put and so we're kind of pruning that index using that pop feature. Now, I don't want to go too much in depth. I really want to talk about the fundamentals of these things, because ultimately when we add fors and ifs and other control structures, we're modifying and we're working with the basic API of the list. And I just want to keep it simple right now. So I appreciate it. Good work.